On July 7th, the Dawn mission, led by UCLA professor Christopher T. Russell, will be launching its spacecraft into outer space to explore 2 asteroids. Daily Bruin Television sits down with Britney Schmidt, the only UCLA graduate student to be working on the Dawn mission, to discuss what she believes is the significance of this launch and the future of space exploration.
Idea that if we could send a small spacecraft anywhere in the solar system, what would we do with it? And their idea was that we would go to these 2 asteroids because it's the earliest snapshots of our solar system. These are planets that started to form and didn't get big enough because of Mars and Jupiter, but it's the most interesting place in the solar system if we want to know where we came from. A lot of the time, our intuition is that when we hear the word asteroid, we think of small rocks, little pieces, broken up pieces of material. Vesta is actually almost a sphere. It's very, very round, which tells us that its internal state is that it's melted, causing differentiation. So the heaviest stuff, just like in the Earth where we have an iron core, there's an iron core probably at Vesta. In the case of most meteorites, we have kind of an idea of what kind of parent body they came from. But for Ceres, it doesn't seem that there are any. And so there's a lot of ideas as to why that may have happened, but one of the biggest is that Ceres has a very low density as far as we can tell. Some people think that could be from a lot of pore space, or it could be because it has a lot of ice. Water is a very low density, and so what we think may have happened with Ceres is that it formed a little bit later and has kept a lot of that water in the form of ice, or maybe even liquid water to this day, below a covering of clays and materials. It's amazing what NASA and what scientists can do with a small amount of money. It is relatively small. $400 million sounds like a huge amount of money compared to what we're spending on other things. It's minute. What we're doing is searching for our origins. How did we form? How did the planets in our solar system form? And if we can tell that, maybe then that gives us a little bit more insight as to how we're unique or how we're not unique. And so if we can look at the earliest stages of our formation, we can maybe look at other early forming solar systems or older solar systems in the future that, if we can detect them with these larger telescopes, and maybe able to discern why we have life and other places don't, or look for those places that are most likely to have life.